All right. Good afternoon. Good evening. I have had enough challenge today. Just for me to get connected to the internet, it was a little bit difficult for me to. That's why I've just decided to do an offline video. Then when I'm done presenting it, I'm going to upload and then send you the link. Now, what I wanted us to discuss today was the oxides. Oxides was a topic that I wanted us to discuss. So without wasting much of the time, let's look at oxides. Now, what are oxides, or what is an oxide? And by the way, that oxide there, okay, I'm going to reserve that for some time later. Now, what is an oxide? An oxide is, so this is a compound, and a compound that forms when oxygen reacts with an element. That's a simple definition I'm going to give about an oxide. Is that an oxide is a compound that is formed when a metal reacts when oxygen reacts with an element. There, I just left it open-ended. An element, we don't know the nature of an element. Is it a metal? Is it a non-metal? How many electrons does that element has in the how many does it have in the outermost shells? That the outermost shell, that information is not given. An element. So how do you show that? We're saying they react. Oxygen reacts with an element. So we're going to say element plus oxygen to form oxide. That's a simple demonstration I'm going to show. We are saying an element reacts with oxygen. The plus means reacting element and oxygen to form an oxide. There. Now, the nature of an element which is reacting with an oxygen is going to help us determine, or is going to determine the type of an oxide which is formed. Because basically, there are four types of oxides. We've got a neutral oxide, we've got a basic oxide, we've got an acidic oxide, we also have an amphoteric oxide. So now, without wasting much of the time there, let's look at the classification of oxides. Classification of oxides. Like I said, there are four classes, there are four types, but I'm going to look at them one after the other. So the first one here, we're going to look at the basic oxide. The basic oxide. Basic oxide. Now, what is a basic oxide? A basic oxide is an oxide of a metal. So in short, this element here must be a metal, but not just an ordinary metal, because if the element is zinc, if the element is aluminium, if the element is lead, that is going to change the type of an oxide. But all in all, I'm saying this is an oxide of a metal. Now, why are we saying basic? It being a base, it reacts. A basic oxide reacts with basic reacts with water to form an alkali. Then this basic oxide reacts with an acid to form a salt and water. So these are the properties of basic oxides that we can look at. One is It's just an oxide of a metal which can react with water to form an alkali, and which is also maybe base. Then this oxide reacts with an acid to form salt and water. So how can you demonstrate the formation of an oxide? So how do you demonstrate the formation of an oxide? This oxide, how is it formed? The formation of an oxide. So we are saying you need to have a metal which reacts with oxygen to form an oxide. Number one, the element that we can look at is magnesium. So when you have magnesium plus oxygen, then you're going to form magnesium oxide. So that, if I'm to balance it up, I'll put a 2 here. I'll also put a 2 there. So this is an example of a basic oxide. Which other one can we look at? We can also look at sodium. 2. We can also look at sodium, nandium plus oxygen. Then you're going to form sodium 2 oxide. Okay, so that if I'm to balance it up, I'm going to put a 2 here and a 4 there. Okay, other one that we can look at is in group 2, you can talk about calcium plus oxygen to form calcium oxide. You can talk about group 1, you can talk about potassium plus oxygen to form potassium oxide. So that's why I was saying that this is an oxide of a metal, because the magnesium is a metal, sodium is a metal. The third one can even put lithium, but no, lithium is very strong, it's a very reactive element. I'm going to put potassium. So potassium plus oxygen, then you're going to form potassium oxide. Potassium oxide. But if I want to balance it up, here there are 2 oxygen, 1 oxygen, so I'll put a 2. Now there are 4 oxide or 4 potassium, then I'll put a 4 there. Remember, sodium and potassium, them belonging to the same group of the periodic table, group 1, the way they are going to react will be similar. So these are good examples of basic oxides. So we can have calcium. We can have calcium oxide. We can have calcium oxide. We can have aluminium. Calcium oxide. We can have potassium oxide, and you can also have copper oxide, iron oxide, because those are oxides of metals. So that's how we can form these oxides. But what are the characteristics? I said the characteristics of these oxides are: 1, these ones, they react with water to form an alkali. Why? Because these guys react with water. So the other characteristic that we can talk about is that if they are soluble, for it to react with water, definitely it must be soluble. So take note of that. The other characteristic of these basic oxides is that they are soluble. That is why they are able to react with water. Now, having said this, let's now look at we've looked at one oxide, which is a basic oxide. Let's look at another oxide. If this is basic, let's look at an acidic oxide. What is an acidic oxide? What is an example? And how is it formed? What are the characteristics of these basic oxide or acidic oxides? Them being acidic, remember I said these are basic because when they react with water, they form a base. Okay, when they react with water, they form an alkali. A base which is soluble, they are called alkali. So now these other ones which are called acidic oxides. Acidic oxides. What are acidic oxides? Acidic oxides, these are, if the basic oxides are oxides of metals, then acidic oxides are oxides of nonmetals. So these are oxides of non-metals. These are oxides of non-metals. Remember, non-metals are those elements that have got that are able to gain electrons. Those elements that have got the ability to attract electrons, those that have got the highest electron affinity. Those are the ones which are calling non-metals, such as sulfur, such as nitrogen, and many more and many more. So now let's look at examples of these acidic oxides. Remember, don't forget that these are oxides of non-metals. So what examples can we look at? We can look at carbon. We can look at carbon. When carbon reacts with oxygen, forms carbon dioxide. Now, why are we saying it is an acidic? Why are we saying carbon dioxide is an acidic oxide? Is because when this reacts with water, it forms carbonic acid. These are called acidic oxides. It is because when they react with water, they form an acidic oxide. We're going to look at the formation of acidic acids later. Then the other one that we can look at is nitrogen. When nitrogen reacts with oxygen, it forms nitrogen dioxide. It forms nitrogen dioxide. To balance it up, I can put a 2 here and a 2 here. So this is another example of an acidic oxide. Remember where we're coming from. We're saying these are acids, these are oxides of non-metals. Carbon is a non-metal, nitrogen is a non-metal. The other one that we can look at is sulfur. So when sulfur reacts with oxygen, it forms the sulfur dioxide. It forms the sulfur dioxide. So this one is also another example of an acidic oxide. But we also have this stubborn one, which is so this one is carbon. We know the names. This is carbon dioxide. This one is nitrogen dioxide. This one is sulfur dioxide. But there is another one which is called sulfur trioxide. Trioxide, meaning you're going to have 3 of the oxides. So the other example of acidic oxide is the sulfur trioxide, because once this sulfur trioxide reacts with water, it forms a sulfuric acid. And then when this sulfur dioxide reacts with water, it forms the sulfurous oxide. Now we are saying that these are acidic oxides. Why? It is because when they react with water, they form an acid. So let us see. Let us prove, because chemistry is all about proving. If you get to have something, then they say this proton is positively charged. How do you prove? You take it in the lab, you use powerful machines to determine the charge on the proton. If you say that water dissolves this, water is a polar solvent. How you get that water? You take it in the lab, you start analyzing the water. Is it polar? You do the geometry, the C2V, the D infinite H. You get to prove that water indeed is polar. With the polarity, you find the bond length, the bond angle, and things like that. You prove that water is polar. So now, how can we prove that indeed these guys here are acidic oxides? Because this is the only thing that will make you and I to distinguish one oxide from the other. They can give you this as an oxide. How do you know that it's an oxide? Is by looking at the characteristics. So what can we say about these acidic oxides? What we can say about these acidic oxides is that they react. They're also soluble. Yeah, because for them to react with water, it means they are soluble. So one of the characteristics is that they are soluble in water, and them being soluble, when they react with water, they produce an acid. at times they'll ask you, give you an example of an oxide, then they'll say, what type of an oxide is it? If you give its type, then they'll also ask you to say, give the characteristic of such an oxide. So the characteristics: one, soluble in water; two, oxides of nonmetal; three is that they react with the water to form acids. That's why they are called acidic oxide. Okay, so how do you show that? We're going to have an example of carbon dioxide. Carbon dioxide reacts with water. We are going to have 2 hydrogen carbon, 2 oxygen plus 1, which will give us C. This is carbonic acid. Carbonic acid. The other one is sulfur dioxide plus water. So we are going to have H2SO3, which is sulfurous oxide. Sulfurous acid. The other one is sulfur trioxide, sulfur trioxide. When it reacts with water, we are going to have H2S3 plus 1 SO4, and we know that this is the sulfuric acid. Yeah, and many more. So this is how we can prove to say that is an acidic oxide. But if you look at carbon monoxide is not an acidic oxide. Why? Because if you get carbon monoxide plus water, you are going to have H2CO2, and that is not an acid. So because of that, we can say that carbon monoxide is not an acidic oxide. What else can we say about this? Because these guys are acids, these guys are acidic oxides, they are acids. Therefore, they can also react with the bases to produce salt and water. Because these guys are acids, in a similar manner, basic oxides can react with acids to produce salt and water. Even these acidic oxides can react with the alkalines or can react with bases to produce salt and water. And how can you demonstrate that? How can you demonstrate that these guys can react with bases to produce salt and water? And this is how you can prove. Let me try to see if I can find something to demonstrate that these guys here can react with the bases to produce salt and water. You can pick of sulfurous oxide. Can you use sulfurous oxide? Okay, maybe let's just use the carbon. Maybe let's just use the carbonic acid, the carbonate, the carbon dioxide. How is carbon dioxide reacting with the base to produce salt and water, which is another property? Another property is that, maybe let me write it here so that I can write the example thereafter. So how can you demonstrate that the fourth property is indeed true? The fourth one, which states that they react they react with the bases to form salt and water. To form salt and water, how can you demonstrate that? You can use carbon dioxide plus a base is sodium hydroxide. So when we get to have that, we can demonstrate that this carbon dioxide here is going to react with that, and then we're going to have sodium carbonate plus CH2O. It's just a matter of balancing up there because we've got oxygen here. So we are going to have carbon dioxide plus sodium hydroxide, which is a base, an alkaline for that matter, to form sodium carbonate, which is a salt, and then plus the water there. The other one that we can use is sulfuric acid, is hydrogen, sulfur dioxide, or maybe sulfur trioxide. So you can use sulfur trioxide plus sodium hydroxide, which is a base, excuse me, and when this reacts, we are going to have sodium sulfate plus water. So you can say that this is salt here and this is water, which is proving that method there. So all acidic oxides, one, they are soluble in water. Two, when they react with water, they produce acidic salts. Three is that they react with bases to form salt and water. And then the other one is that all these acidic oxides are oxides of nonmetals. At least there is a clear-cut distinction between acidic oxides and basic. Basic are of metals except aluminium, lead, and zinc. All the metals, when they form when they react with oxygen to form a metal oxide, that oxide is a basic, provided an element which is a metal is not lead, the element is not aluminium, the element is not zinc. So away from that, we can look at the third type of an oxide. The fifth type of an oxide, which is called a neutral oxide. The third one is a neutral oxide. Now, what are these oxides? Neutral oxides. What type of oxides are they? So neutral oxides are oxides of nonmetal again. The neutral oxides are oxides of nonmetals. Neutral oxides. They are oxides of nonmetals. But except that with these, even if they react with water, acids are never produced. That's the difference. The difference is that these acids, these oxides, even if they react with water, an acid is never produced. Okay. So what are examples of okay, maybe let me try to write them here. We are saying that the neutral oxide, these neutral oxides are oxides of nonmetals. They are oxides of nonmetals. Examples: one, water itself, H2O, where hydrogen is regarded as a nonmetal. The other one is the nitrogen dioxide. Nitrogen dioxide, dinitrogen monoxide is an example of a neutral oxide. The other one is carbon dioxide, carbon monoxide. Then the other one is nitrogen monoxide. So these are examples of acidic oxides. But how do you prove? Because this, when the water reacts with water, there's no acid formed, of course. When the nitrogen dioxide reacts with water, there is no acid that is formed. Because even if I say H2NO2, that's not an acid. That's not an acid. Carbon monoxide, even if it reacts with water, there's no acid there. Unless it was 3, that's when we could have said that is carbonic acid. And if here was 1 and 3 oxygen, could have said that is nitric acid, but that does not happen. And nitrogen monoxide, even if it reacts with water, there is of course here there are 2, because there are 2 here. There is no acid which is formed. So because of that, these guys are neutral. They are neutral. They do not have properties of acids, of acidic oxides. They do not have properties of basic oxides. They are neutral. That's why they are called the neutral oxide. And those are examples that I've written right over there. Yeah, these neutral oxides do not show any property. They do not show any property of acids, not even properties of bases. That's why we call them neutral oxide. They are just palololol. They do not have those properties. So these examples must stick at the back of your mind. One, we've got water, which is dihydrogen monoxide, H2O, and then the other one is carbon monoxide, CO. We have nitrogen monoxide. We also have dinitrogen monoxide. Those are examples of neutral oxides. Then the last one is amphoteric. Amphoteric oxides. What are these amphoteric oxides? One, they are oxides of nonmetals. Oxides of metals. They are oxides of metals. What else can we say? And these metals should either Pb, lead, zinc, and the aluminium. Only those 3. Any other element, if you put iron there, it's not going to be an amphoteric. It's going to be a basic. If you put copper there, you put sodium, you put magnesium, you put calcium, those are going to be basic. But we're saying oxides of metals, and these are the only metals. These ones have properties for both metals, properties of both basic oxides and the acidic oxides. So if these guys have got the properties of basic oxides, that means they can react with if they have the properties of basic oxides, they can react with acidic oxides to form salt and water. And if they also have acidic oxides, meaning they can react with basic oxides to form salt and water. So examples are those ones. You can talk about Pb oxide, zinc oxide, and aluminium oxide. So those are examples of amphoteric oxide. Take note of this. They are oxides of metals. The only metals that are mentioned is lead, zinc, and aluminium. If the element there, which is a metal, is calcium, it being magnesium, lithium, sodium, is not going to be an amphoteric oxide, but it will be a basic oxide. But because we are saying these guys can react with, they have basic properties, they can react with acids to form salt and water. Let's see how we can do that. So if you get zinc oxide plus an acid, what acid can we use? Zinc oxide plus an acid, which is HCl. We are going to have zinc chloride 2 plus H2O. So we can have such an element. We can have such a reaction where zinc oxide is an amphoteric oxide reacting with a base to reacting with an acid, meaning for it to react it should have basic properties. Zinc oxide plus hydrochloric acid forms a salt and water. The other example that we can look at is aluminium and phosphoric acid. So aluminium 2O3 reacts with the phosphoric acid. We're going to have aluminium phosphate plus H2O, where aluminium phosphate is a salt and then the H2O is water. But meaning for them to react with acids, they have basic properties. Now, how can they possess acidic properties and they react with bases to form salt and water? How can we show that? They also have acidic properties which enable them to react with the bases. They also possess acidic properties to enable them reacting with the bases. And what example can we look at is, let's say we can use zinc oxide. We can use zinc oxide plus sodium hydroxide, because this is a base. This is a base. Okay, and once that reaction takes place, we are going to have a salt which is so we're going to have sodium Zn and then O plus H2O, and this is a double salt. This is a double salt which is called sodium zincate, which is a salt, an example of a double salt, which is called sodium zincate. Okay, we can also look at another one, aluminate. So you can have aluminium, you can have aluminium oxide. Aluminium oxide is an amphoteric oxide plus sodium oxide, and when this react, you're going to have aluminium combining with the sodium with one oxygen, which is going to be N, which is going to be NaAlO plus H2O. Now, what is the name of this? This is also a double salt, which is the sodium aluminate. So the name of this double salt is the sodium aluminate. Yeah, so that's how we can show that these acidic oxides, these amphoteric oxides can react with bases to form a salt. And a good example is zinc oxide, which is an amphoteric oxide possessing possessing acidic oxides, making it possible to react with the base because it is acting as an acid. So we're going to have a salt which is sodium zincate, which is an example of a double salt, plus water. Why are we saying double salt? Double salt, these are salts that have got more than one metal in them. The other one is aluminium oxide plus sodium hydroxide, which is going to produce sodium aluminate, which is an example of a double salt because it's a salt that contains two metals. And that is where we end for today. So I'm going to send you work. Goodbye.